Today we're going to begin Chapter 8, Lesson 1, which is an introduction to vectors. And we're going to take 2 days to begin introducing this idea of a vector. Okay, what is a vector? Okay, a vector is a quantity that has both magnitude and direction. A quantity that has both magnitude and direction. Okay. Magnitude is also known as a scalar. Okay, so it's a single real number that represents a physical quantity. Okay, an example of a magnitude could be distance, speed, or force. Now, in example number 1, we are going to state whether each quantity is a scalar or a vector. Okay, in example 1, letter A, we have a hockey puck shot northwest at 60 miles per hour. Okay, so there's 2 things that I noticed. It has magnitude. Magnitude can be speed at 60 miles per hour, and it has a direction. The hockey puck is shot northwest. Since it has both a magnitude and a direction, this scenario is representative of a vector. Oh my goodness. Okay. Now again, because there's 2 things. It has direction. The direction is northwest. And it has magnitude. The magnitude is 60 miles per hour. Okay, number 2, we have a tennis ball served at 110 miles per hour. Okay, so when we serve the tennis ball, we are given a speed, 110 miles per hour. However, we are not given any direction. Therefore, this situation represents a scalar. Okay, and it's a scalar because if I'm asked to identify the direction, there's none. Okay, but the magnitude we were given at 110 miles per hour. Okay, I would like for you to pause the video, try letter C, and when you're ready, hit play. Okay, so a sprinter is running 100 meters north. Okay, 100 meters represents our magnitude because it's a distance, and north is the direction he is running. So this situation represents a vector, and the reason is because it gives us both speed and direction. The direction that he ran was north, okay, and the magnitude was 100 meters. Okay, now vectors are represented graphically, geometrically, using arrows. Okay, a vector has both an initial point and a terminal point. The initial point is called the tail. That's the point at which it begins. And the terminal point will always be represented with an arrow, okay, and that's called the tip. Okay, so we have a tip and we have a tail. A vector is considered in standard position if you put it on the coordinate plane, and the tail of the vector, or the initial point, is on the origin at 0, 0. Okay, so if you look at this example, okay, I have vector A, B, okay, and we can represent a vector in one of 3 ways. Most of the time, it's just given as a boldface lowercase letter. Okay. So this would be vector A, because notice it has a little a along the vector. Okay. Sometimes, especially when you're writing with marker or pen, and it's hard to tell whether something is bold-faced or not, then we put a vector symbol above the A, which looks like that. That's vector A. And you can also name the vector using the initial and terminal points. So my initial point is A, the terminal point is B. So I could name that vector AB. Now a vector has both speed or magnitude and direction. Okay. For this particular example, the angle between the vector and the positive x-axis gives us the direction of A, which is at 35 degrees. Okay. Most of the time we call these quadrant bearings. Okay, and quadrant bearings are in terms of north, east, south, and west. Okay, so if you think about your compass, my son likes to say never eat soggy waffles, but north, east, south, and west, never eat soggy waffles. Okay. Most of the time, we give the angle from the direction north. Okay, now this is a right angle, so 90 minus 35 is 55 degrees. So another way to name that angle is north, 55 degrees, and it's going in the easterly direction. So north, 55 degrees east. Okay. This is called a quadrant bearing. Okay. Now we also have what's called a true bearing. Now a true bearing always starts at north and can go around 360 degrees all the way back to north. So this would have a true bearing of, now because 360 degrees is three numbers, we always use three numbers. So it'd be 0, 55 degrees. So we call that a true bearing or a true heading. Now the magnitude of a vector is the length of a vector. Notice we're given a scale, 1 centimeter is to 5 feet per second. Okay. So let's just assume that this actual vector, AB, okay, is 2.6 centimeters. Okay, then that means I would have to multiply 5 by 2.6, which means this vector actually represents 13 feet per second. Okay, this is the end of example 1 in chapter 8, lesson 1, Introduction to Vectors.